Hello, welcome to another episode of Coffee and Compressed Air with Dr. Elvira Rakova and myself.
Hello, everyone.
So today is fun, I think, because it happens every day in these manufacturing facilities. I mean, they identify an issue or something that they need to fix, and then what? You know, now what's the next step to get it in there and assembled and up and running again? So this is maybe more practical uses for some end customers or people who support end users and manufacturers.
Today I just wanted to talk also about the projects. Why so many projects in compressed air failing? So I know that we announced like from pressure drop to purchasing, and I think people felt that, oh my god, they're gonna sell their software again. And but, but I wanted actually to talk today about why so many projects fail when the problem is identified. Or let's say even so that there is some crisis happened on the production line, then everything happens super urgently. People are looking for experts. The experts are coming in. The data is collected. The information, then everything is calculated, analyzed, and experts are telling. So this is, you have a pressure drop. You need to change the piping, and then the company disappears. And you would think probably they went to another customer and they bought this piping, or they changed this component, and it's okay. But then this customer comes a year later, exactly with the same problem, running the same production line. And I remember that I saw some statistics and of the projects, the ones that have been implemented after the audits or after the projects, but so many compressed air projects fail in terms
Mhm.
that they start always like with a huge problem and somehow they find like a duct tape and then the things work. Or I mean, me and you will know this. We have customers that come back like 1 year later, and then they exactly with the same problem. And is it like not enough contractors? Is it not enough experts? Not enough people? Is it a people thing? Is it a technology thing? Is it the timing? Is it the budget of the timing? So I think it's even like more like just like a philosophical question on how and where to understand what is actually happening with your system. And
Mhm.
even if I'm not going only from the perspective of the problem, such as a production line is not running, there is not enough air, there is a bad quality or something like that, even if from that we are going into the energy managers, and here I think even more projects failing. I had so many diagnostics analysis projects done in my life that were never been implemented after for the energy savings purpose. Of course, at the beginning, I was taking it very personally. So, and
Yeah.
then I went through all the 5 stages of grief and acceptance and anger. and, and then the stages were changing in my life. And then I just started to realize that uh, what are the main obstacles also for people. I started to think what are the main obstacles within the organizations, and I would say the first obstacle is actually understanding, especially if it is not a urgent project where there is a problem in the production, but rather like it would be nice to spend less energy, for example, like nice to have like a better production, a quicker production. The identification, the localization of the problem. So I saw recently the post telling that this company has like compressor room is like fantastic. It's like in 1% of the benchmark, and then the compressor system is fantastic. And I asked, is it including the demand side or it's just a compressor room, just 2 square meters of compressor room? Like, no, not including the demand side. And then you cannot call the system if you don't include the demand side. So
Yeah.
call it the compressor room. And so this is the problem also for a lot of customers. So when they think about, it's not that their problem that they don't know, it's just like the perception of our industry, if we talk about the compressed air, it should be a compressor room. And whenever we talk about the entire system, it already gets very complicated. So it is the localization of this problem, identification of the where the big potential is. And then the biggest part, I think, it's explaining, and not even like explaining, but finding this common ground for different experts in the facility,
Mhm.
from the maintenance to energy managers to purchasing, to start moving the projects. Because usually it is a very enthusiastic energy manager, and he wants to implement the projects and do like everything. But then at the end, the quality says it's not possible, the pressure says it's not possible, and finally, after 2 years, when he arrives to the to that to convincing all people,
Yeah.
there is no budget anymore. And this is what I wanted just to today to give a guideline from my side as a person been working on the 15 years on the compressed air systems, so maybe 13. I think I added 2 years more, but I always say 13 years. I need now to recalculate it. But anyway, so if I said something different in another coffee, just let me know. So, but in general, from 2012, I'm working in the compressed air system, and the how to start and how to bring all people on the board. When you are as a maintenance manager, yes, you said you have a problem, the pressure drop, but how you arrive to this purchasing? You
Mhm.
arrive very easily, right? You just create the project, you download bill of material, you send it to the supplier. But I think it is even more than that, and I wanted to share our new very simple tool that you can access from our new website. And this is basically the called efficiency chain. And what I want to talk about. So we have a very simple representation of compressed air system. And if you are a manager or operation manager who says, I have the problems of the pressure drop, and I actually can even check and explain my colleagues why I have here a pressure drop. Because I have here certain pipe length, for example, I know 5 meters. And diameter of this, it is, let's say, 20 millimeters. And here you see I have a 1 bar of this pressure drop. So as a usually for maintenance operation manager, this is their worry. So the CFO of the company doesn't care about this so much. The quality doesn't care so much because they need a certain pressure. So what they say, deliver me a high pressure, so go into the compressor room and
Mhm.
put up the pressure in the compressor room to compensate the pressure drop, or make for me a bigger receiver tank, for example. So all these kind of things that no, there's always one stakeholder in the company will be unhappy with this. So and for energy manager, it will be higher energy cost, quality will be happy. If we want to reduce the energy cost, maybe the quality will be unhappy. But
Mhm.
this is the very simple problem that becomes a huge uh, obstacle in the entire operation of our entire facility. And this is where usually it stops and where usually it fails. So we just simply go and we increase the pressure level in the compressor room. So if we apply this pressure drop here, you can see that the here we need to increase the pressure level in the compressor room so that the demand side will be adequate, but the energy cost will be higher
Mhm.
here. And this is, I think, it's an extremely simple example to show all the stakeholders that
Mhm.
listen, if we just simply solve the problem in the distribution because the compressor room works fine, the treatment is okayish, so still to do something on treatment. The distribution is in very bad condition. The pressure strategy is okay for things that we see now, so it's not overpressurized. And
Mhm.
the storage buffering is also fine. The demand is adequate. The compressor room is adequate. But here we have something that we need to solve, and this is exactly the distribution. So this first step of the localization of the problem, in my opinion, by giving a very simple map, and again, this is not like a monitoring system, it's just something that we walk through the facility within 1 hour, 2 hours, and we just like put the information, calculate something. If something is missing, we already
Mhm.
can see what is happening in our system. So, and basically, based on this, we can see, okay, I actually can reduce the pressure and I can reduce my system becomes even more adequate, but it's more overpressurized. So I can reduce the pressure level here. It will be reduced cost. It will be adequate pressure drop here. I have other adequate pressure drops within all my facilities, but the only thing that I need to do is to increase the piping diameter here, or I can need to find some. So it means I need to do something with the distribution. So, and then we need to understand exactly what has to be done there, because maybe pipe diameter is fine,
Mhm.
or there are some restrictive components, there are some clock filters, there is some other information. But here I just showed you here in an example that you actually can check if the pipe diameter is adequate here or not. And this is the first step that I usually do. For example, recently I was in one facility where I thought it was a huge pressure drop. I thought that the piping was not adequate. So I checked the flow rates, and then I
Mhm.
did the calculation, and the piping was like 32 millimeters. I had just a zero point 0.1 bar for pressure drop. So it was
Mhm.
completely adequate,
Okay.
meaning that we need to go to the second step and check other components there. Maybe there
Mhm.
are many elbows, maybe there are some connectors, maybe there is some problems in distribution. I need to go into the deep in details. But if I already check the pressure drop of my piping for this flow, it's
Mhm.
already bigger than a half a bar. It means that I already need, this is already my problem. And from
Mhm.
here, I need to redesign completely my distribution system, the header, for example. And this is very easy. So I just check the pipe that is good for me. And for example, I say, okay, now I need to put the 32 millimeters pipe here, or
Mhm.
some other piping. So, and this is basically how the logic works. And if I need to, if my piping is fine, then I need to go in, I can go into some quick savings tool and see another calculations of the dry or the pressure drop calculations.
Mhm.
But from this part, I already can go into my baseline studio and get my easy CAS, and just I draw a piping. And for example, just by drawing a piping, I already can see where the problems are. Of course, I'm not gonna show the project, but based on that, I can easily solve the problem and convince my colleagues that, listen, your life will be way better if we maybe can find the time when production is stopped, and
Mhm.
when I can finally solve the problem. So, and the main point from my side why so many compressed air projects fails or are not implemented, it's the communication between the teams.
Mhm.
So, and this is, I think, it's extremely important, and was the topic of my coffee of today. So I know that we always need to be in our 20 minutes, but I just wanted to give this ideas or like insights how we
Mhm.
can facilitate the project and how we can communicate the problem uh,
Yeah.
between different team members.
Mhm. Yeah, it makes sense to have it laid out that way because I feel like most like auditors or even salespeople, like we know what parts our components can fix. However, they also impact all those different parts. But I I think I can say this, until now, there wasn't really anywhere to put that information to see it. Okay, if I move this a little bit or adjust this, this is what it's going to do. And then here are some numbers. Um, and I think that was really missing. And just to make it simple enough that you can go in there, collect some data, just, looking, asking questions over the phone, what they have. Of course, it'll be different for everybody. But like you said, we see so many compressor rooms being outfitted with the best technology, like crazy AI sensors, everything, adjusting, but all of that is adjusting to everything else in that efficiency chain that we just saw.
Mm-hmm.
So, um, yeah, I think it could be really useful. I'm interested to see what people think about this one. And of course, I like that we are constantly developing new things, like our team, just based on what we see. And it's like, okay, this is what we see. Maybe people aren't ready for this level of detail, as far as a digital twin, but this is something that can show people exactly where they need to dig deeper. And especially for salespeople to offer this as uh, an added value. Like last week, we covered how can you add value? How can you bring something else to the table other than just your specs, right? Like, here's my specs. I can tell you it, like, according to these calculations on an Excel sheet, I can tell you what it'll do. But now you can go say, hey, this is what it's going to do along your entire efficiency chain, and this is what else you can adjust. Just to give
Yeah.
them a complete solution to some of these complex.
Exactly. Yeah, and I think what I wanted today to show more on the how to model the systems, because like I see that we get a lot of questions. For example, we have the drawing in the AutoCAD. Can we do the same drawing? We need the software that just draws like the lines.
Yeah.
So can we do also here? Of course, you can draw the lines, and there are so many softwares that you can draw the lines. And the people usually ask us, okay, but I need to have a bill of material right after that. And it's
Mhm.
also extremely important to have. So you can upload the bill of material, and you can draw with the components that are already in the system. So
Mhm.
this is wonderful. But I think the main question is here that you need to know what you need to draw. So you need to know what has to be the diameters. You need to know what is the pressure. See what are the, because it's not just like there has to be calculations. It's like a fundament of the building. When don't just like architects don't just like draw the fundament of base of the building. You need to
Mhm.
have the calculations of the endurance of a lot of like mechanical strength and so on before this fundament is actually even like drawn in like AutoCAD. The same
Mhm.
thing also for compressed air system. We first need to calculate it. Otherwise, we end up with the or super large pipes that maybe don't hurt the production but they create other problems. Or most of the times it's the undersized systems. And I don't want to even like go into the some sophisticated calculation modeling on the simulation, because I think our industry really need this understanding, like from when, like where the problem is happening,
Mhm.
what is happening, where is the location, why it is happening, how I can solve it. So it's extremely very simple steps of the critical thinking. So how I can solve it, and only after that already perform the project, do the drawing, do the bill of material, and so on. Because before that, it's not even like possible to do. And I think I want to go more into the simple ways and explain that starting very very simple, it
Mhm.
already gives you so much information rather than like opening the large AutoCAD with the just the blue line drawing. And this is wonderful, but it's not going to bring the value to the customer. It's not going to bring the more information on the optimization of the process, because compressor is not just the piping, but it's also all other the generation of this and also the use of this. So
Mhm.
this is why I think that it's extremely important to start from the holistic picture until the demand is extremely important. It doesn't make sense just to go to check only the compressor room.
Mhm.
So it's has to be considered as the part of the system, as a one component. It's always the part of the system. I
Mhm.
see we have some questions
Yes.
from Mohammed. Hi Mohammed, how's everything? Have you developed any machine learning, I think you mean, with ML model for compressor management, adding automation or time efficiency into operations? I think I need to understand this question better, honestly. I don't understand quite well, but the machine learning model, no, we didn't develop them yet, simply because to develop a machine learning model, you need to have thousands and thousands and thousands of data. And we didn't do thousands and thousands and hundreds of thousands of the broad factories yet. So we have an algorithms for this, but first we're developing the physics based models, and based on these physics-based models, then we're integrating machine learning models to analyze the data collection. So we use it for the data collection because the models already exists for that. For data interpretation, we use our physics-based models, and we don't have the compressor management. So I wouldn't management. I always feel it's like a monitoring. It depends on how we use this word. So, but we have a series of simulations, modeling tools to from different types, different levels, from simple calculators to simulation tools. Adding automation or time efficiency in the operations. Mohammed, it's too many fancy words. Automation, time efficiency, and operations. I think about this, but to be honest, it's Friday evening. I cannot grasp. But I'll think about it and I'll answer you. So yeah, it's time efficiency. What is time efficiency? Time
Mhm.
efficiency, is it a controller of a compressor room? Is it controller of the demand side? But yeah, I'll be happy to discuss this topic more.
Mhm. Perfect. All right. Well, I think we're going to end this one. We had another Friday show today. We have lots of amazing things that we were working on. So please be patient. I know I've been like dropped off of LinkedIn because I've been so deep in some other work, but we will have some fun stuff coming up soon. And we will be out and about here shortly this year also. So we'll be posting where we're going to be and what we're going to be doing. And then you guys always know where to find us.
Yes, and enjoy your weekend. Thank you very
Yeah,
much.
most importantly. Thank you.